Hello, my name is Parusha, and this video I will be demonstrating my work for Lab 6 Live Classification and Performance Evaluation Lab. So the goal of the lab is to build and evaluate a malware classification system using machine learning. So basically from lab 5 continues, which we selected the best performing model. So in this lab, we'll prepare a realistic testing pipeline like tune hyperparameters, perform automated model selection, and finally we're gonna evaluate the performance of the classifier. So I'll walk through each task, show the script used, and explain the results. So let's start with the task one, which is dataset splitting and hosting. So first I'm gonna just show you the file for the lab. These are the all Python files required for this lab. So I'm gonna just start with nano makeup. Yeah, so this is the script for my task one here. So basically the script here doing is I'm gonna first run. Yeah, so here you can clearly see the basic. I created a separate testing data set to ensure the classifiers in the evaluated using unseen samples. So using the make test.py script, I'm gonna randomly select 30 malware and 13 Benin files from the reduced data set, which selected items were saved in the file called MD5. So I'm gonna quickly show you the MD5 file. So it's back in the data ls, as you can see here the MD5, and I'm gonna show you the file MD5 file as well. And as you can see here are the Benin and the malware files over here, which is MD5, which stores like the sample MD5 hash and correct label. As you can see here the labels, and the remaining samples are stored in reduced dataset underscore train.csv. So I'm gonna quickly show you the -l reduced dataset dot csv. This is the actual file which is having 702, and right now we took 30 malware and 30 Benin files from here. So now the new file, which is reduce dataset like dot training one, it will show you around, it will show you the less files. As you can see it's just showing 642. So out of this 60 files we already used it over here. So I transferred the selected test binaries through the Kali VM and hosted through Python HTTP server, and it stimulates a real world scenario which samples are fetched remotely for the live scanning. And currently I did from the Ubuntu monitoring machine, confirming that the dataset hosting was working. So this is all for my task one. So now let's move to the task two. Yes, so for task 2, I'm going to quickly open my Python code. Nano Lab 6A. 6A. Yeah. So this is my Python code for manual hypervisor tuning with cross validation, which is task 2. So here in this code, I'm gonna like improving the model performance by using fine tuning hyperparameters using my lab 6a script, which is I'm using, and I performed a 10-fold stratified cross validation on a svm classifier. As you can see over here, it's explaining all the things here. And I experimented with the different kernel types such as linear, polynomial, rbf, and sigmoid, along with the multiple values for the parameter c. For each parameter combination, the script calculates the mean and the standard deviation of the F1 score. So now I'm gonna quickly run this Python code, lab 6a. Yes, so it's gonna quickly run this Python code, and as you can see, it select the 15 features which are over here, and it selects the different kernels like linear, polynomial, RBF, and sigmoid. C values are over here, and scoring for the F1s for the each of the feature. So as you can see over here clearly, based on the results, the RBF kernel with C1 here, as you can see, achieved the highest performance with the F1 approximately score is 0.955. This shows that the RBF provide a flexible decision boundary that works well for malware data, making it performed setting for the further improvements. So this is my task 2. Now I'm gonna quickly move to my task 3. So let me explain the code for task 3. 6b. So this is my script for task 2 be like task 3, which is automated tuning using random search versus grid search. So in this search, I'm gonna like in this task was to automate hypervisor tuning using two different algorithm, which I already said was random grid and random search and the grid search. So the random search script was explore wider parameter space using 500 candidate model, while the grid search exhaustively testing combination with the smaller amount predefined set. So let me show you quickly over here. Run this file, Python 3 lab 6b. Here it's running the quickly 500 candidates for the random search. As you can see over here, I'm running the random search file. So let's just wait for it. Yeah, it ran and it can show the F1 score here 0.985. And now I'm gonna quickly show you the code for grid one. So this is exactly code for the grid one, which is like the grid, while the grid search exhaustively tested combination with the smaller predefined set. Both uses 10-fold cross validation with F1, and the all the data, all the script is now same. So now I'm gonna quickly again run Python 3 lab 6c. So I'm gonna quickly run this grid search method over here, as you can see here clearly, and you can see the result again. So the basically the result shows clearly the random search achieves a slightly higher F1 score of 0.098895 compared to the grid search best score of 0.956394. Since the random search also require fewer evaluation to find the strong results, I select the random search output hypervisor as the final configuration for model training. This confirms the effectiveness of random search for the tuning SVM classifier effectively, basically. And if you want to see, we can see the output as well, dot output, and we can see the output for the both method here. So cat lab 6c. Oh, I have too many lab 6c underscore grid search cv. Yeah, this is the output file which I have saved in CSV for the grid search. It's a long file, and the same here for the random. Again, I'll quickly show you the random file as well. Underscore random. Let me see. Okay. Oh, the random one will be the console one. So yeah. So basically this is the exactly file for the random one. And now let's move to the task 4, final task, model training detection and final evaluation. So for the task, for the first training, I did use cd dot slash script ls. So this is the lab 6d, which is used. This is my script for training here, training the model. So as you can see, I trained the final SVM model using the entire dataset and tuned the hyper parameters identified in task 3. So basically I trained the model, was saved in a pickle file along with the selected feature to stimulate the real malware detection. The model was integrated into the detector script with the scan the 60 unseen test files. Each prediction was recorded in JSON log file, and then I ran the evaluation script basically. So now I'm gonna first quickly run this file, Python 3 lab 60 train, and it's gonna train, and it says it's gonna save and it's gonna successfully run. And let's see the selected features all which I saved. As you can see, these are all the selected features used in the like for training the data set. And then to stimulate the real detection, the model was integrated into detector script which scanned the 60 unforeseen test samples. Each prediction was recorded in a log file. And then after I did that, I what I did and then I did was the final step was evaluation. So for evaluation, I'm gonna quickly run final step Python 3 lab 6e. Okay, let me just give me a second. Yeah, so pyth Python 3 lab 6e underscore offline, and this is the final script which I used was here. As you can see here clearly, I ran the evaluation script and it says the true label and it shows the clear excellent accuracy of around 97%. As you can see over here, the accuracy was 0.97, which is 97%. And as you can see, the precision and the f1 values for both like malware and benign files was 0.99 and malware is 0.95, whereas the f1 scores are both same 0.97. And now let's look at the confusion matrix, the plotted graph which I plotted from here. As you can see over here, this is the confusion matrix I got from the script which I ran like the final evaluation and detection. And here the script clearly says that the almost all the malware files were correctly detected, only few misclassified benign files. And let me show you the other ROC curve graph. Here the ROC curve graph demonstrate a strong capability in distinguishing the malware from benign like files. Compared from the result from lab 5, the improvement was significant. Hyperparameters tuning clearly increased the model precision and general performance, as you can see over here. And that's how I'm gonna wrap my stuff for lab 6. And in conclusion, the lab successfully completed full end-to-end all the task and detection flow for this lab, and I properly split my data set to avoid data leakage and tuned the model using both manual and automated approach. And the final tune SVM classifier demonstrated strong accuracy and reliability, reaching 97 performed. And yeah, thank you for watching my lab 6 demo. Have a nice day, sir. Thank you so much.